Okay, so let's do the first example on stationary points. Find and classify all the stationary points of f of x equals this polynomial, x cubed minus 3x squared minus 9x plus 5. Okay, so first of all, we need to think about what stationary points are. Okay, stationary points are the points when the derivative is equal to 0, right? And we said that stationary points could be a local maximum, could be a local minimum, or it could be a point of inflection. So we have to classify what those are once we find where the derivative is 0. So my first step is to find the derivative, and we want to factor it to find the zeros, right? So I take the derivative, I get 3x squared minus 6x minus 9. I factor that expression out, and I get 3 times x minus 3 times x plus 1. Okay, and so you can see here if I set this to 0 and find the zeros, I have zeros at 3 and negative 1. Alright? So my sign diagram is going to look something like this. Minus 1 here and a 3 here. In this interval, I put in, let's say, negative 3 or negative 2. If I put a negative in here or a negative in here, I would get negative minus a negative, so that would be negative. I have positive times negative times, if I put negative 3, I get a negative, so it would be 3 positive, negative, positive, negative, so that would be positive. Okay? If I put in a 0 in here, I get 0. This would become a negative number, and this would become a positive number, so you could expect that to be a negative, okay, because positive times positive is negative. And over here, if I put in a 4, I would get positive times positive. Okay? Now, this is the sign diagram not of f of x, but of f prime of x. So that's where a lot of students get confused. This is the sign diagram of the derivative, okay? So that means this and this is not the zeros of this function. Okay, we would probably expect this function to look, I don't know, something like that, right? And it could be shifted up or down. Okay? So we don't know the zeros of this yet until we factor it. But the zeros of this tells us the maximum and minimum points. Okay? And so this sort of makes sense in that this would be a local maximum, probably, because I have plus and minus. And remember from our chart that we said as I go here, it's increasing then decreasing, so that would be at x equals 1 is a local max. Okay, from 3 at the point 3, x equals 3, I'm going down and then I'm going back up, and so that we would expect to be a local minimum. Okay, so and that's what we would expect from this graph. We would expect it to look something like this because it's a cubic and it's positive, and with these inside terms it probably stretches it out. Okay, so just to clarify, remember that this sign diagram that we're using is not the sign diagram of f of x or f of x. It's the sign diagram of the derivative of x. All right, good.